Can AI really understand music videos, visuals, and audio without needing a massive, complex system? A new paper shows a surprisingly simple way to do just that, incredibly effectively. Let's get into it. Let's start with a featured paper, Quen Music AV QA 7B, a multimodal model for music audiovisual QA, by Mariam Dashti from Inference Matter Labs. Here's a full breakdown.
First, at the core of our audio processing, we integrate a shared whisper encoder, which is kept frozen to leverage its powerful, pre-existing audio understanding capabilities. This encoder forms the foundation for interpreting all audio inputs, both from the video and the spoken question. Feeding into it, the system uses two distinct paths for audio, one for the video's music and another for the spoken question, which is generated via text-to-speech. Each path uses a dedicated projector, a music projector and an audio projector, to map the shared encoder's output into the language model space. Next, the visual, music, and question tokens are all brought together into one concatenated multimodal sequence. This combined sequence is then fed directly into the Quen 2 VL language model, which uses its own pre-trained self-attention mechanism for fusion, eliminating the need for an explicit cross-modal fusion module. Finally, to ensure musical details aren't lost, the model doesn't just use a single audio summary. Instead, it processes a series of 32 to 64 temporal music tokens, which preserves the fine-grained, frame-by-frame information from the audio. The proposed models, ours, Whisper 30s and ours, Whisper 60s chunked, substantially outperform the Quen 2.5 Omni 7B baselines across all metrics, including overall, audio, AV, and visual. The Whisper 60's chunked model achieves an impressive 97.3 overall accuracy, demonstrating strong performance in this evaluation.
Up next, our second paper out of 3, AI Guardrail Survival Under Single-Cycle Agentic Self-Summarization by Ted Kortler and Arian Abbasi from Harvard University. Let's break down its key contributions.
To start, we're looking at what happens to safety rules after one round of self-summarization, and we've categorized the outcomes. These code categories range from W, welded, where the rule is perfectly preserved, down to X, dropped, where it's gone entirely. Feeding into this, we distinguish between a rule just being present in the text and it actually being effective. The third column directly asks this key question for efficacy. Is the rule text sufficient to apply the restriction? Next, for rules that are degraded, we can't tell from the text alone if they'll work. As the definition notes, its behavioral status untested until replay. This is where our behavioral replay evaluation comes in, to actually test the model's actions. Finally, we found that simply judging the text isn't enough, as even a welded rule might not perform as expected. This underscores the need for validation against an external ground truth, rather than relying on potentially misleading automated labels. In between items probes, deontic rules show a 27% survival rate, which is substantially higher than the 4% for epistemic facts and the 0 to 3% incidental tracer base rate. Under single rule stress probes, rule referent presence is maintained at 38 to 50% for most conditions, significantly exceeding the 0 to 3% incidental fact base rate.
Up next, our third paper out of 3, If Cargo, LLM-Based Semantic Compilation for All-Native Rule Programming Games by Tingchen Su and Sehao Chen from School of Animation and Digital Arts, Communication University of China. Let's break down its key contributions.
To start, we see a robot without instructions on the left. The core idea is that these instructions are written in natural language and then translated by an LLM, as described by the text in the middle. Feeding into this, the player's natural language is converted into a structured format for the game. This is represented by the UI panel, where the input is broken down into an if condition and a then action. Next, this process enables an iterative gameplay loop where the player can express, execute, and observe. We see this in the bottom sequence, where the robot with instructions begins to act according to instructions to ultimately complete the objective. The if cargo method's performance is detailed across various game mechanics, with object picking up and multi-robot L5, generally exhibiting lower thinking times and attempts and higher controllability and adjustability. However, this table does not provide data for a direct comparison against prior work or external baselines.
Those were the top papers. Now let's zoom out. ArXiv received 593 new computer science papers across 54 subfields today. Here are the trending areas shaping the field. Zooming out, the day's research clustered into 5 big themes: LLM agents, architecture and optimization, AI agents, memory, identity, control, world models and visual perception, optimizing AI and data systems, graph complexity and optimization. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries.
See you tomorrow.
Thank you to ArXiv for use of its open access interoperability.